In this lesson, we'll be learning how to graph radical functions. Now, when I say radical, what I'm talking about are roots. Primarily, we are going to be focusing on square roots and cube roots. Okay, so let's start by graphing some square root functions. In order to graph any square root function, you have to first understand what the parent function looks like. So parent function here is y equals square root of x, so plain old square root. And what we're going to do to complete this table is we're going to take each value of x and plug it in. Now, you can use a calculator for this if you need to. If you plug in -4, the square root of -4 will give you an error if you're using the calculator. This one doesn't exist, right? We actually know that the square root of -4 would be an imaginary 2. So it wouldn't actually appear on a normal coordinate grid. Right? Same thing with -1. If you plug in a -1, the square root of -1 would also give you an error if you're using a calculator, because technically the square root of -1 would be 1i, an imaginary number, again, which would not show up on a regular coordinate grid. Okay, so here we pick up with 0. The square root of 0 is 0. If you plug in 1, the square root of 1 is 1. If you plug in 4, the square root of 4 is 2. If you plug in 9, the square root of 9 is 3. If you plug in 16, the square root of 16 is 4. So these are the points that we are going to be graphing. So starting with 0, 0, I'm going to plot 0, 0, 1, 1, 4, 2, so over 4 up 2, 9, 3 over 9 up 3, and I can't get 16, 4 to fit on here, but we understand that this thing would keep going, and the next point that we would hit would be 16, 4. After that, you would have 25, 5, so on and so forth. So the square root parent function we see starts at the origin. It starts at 0, 0. And it just kind of makes this arch going up and over to the right. Now, that is the most basic square root function that you can have. And what we're going to look at next is how do you take that function and move it up and down and left and right and so on and so forth. Okay? If you take the original square root function and you start adding some extra numbers into it, here's what's going to happen. Inside, if you throw in a constant here with x, if you have like an x plus 3 or an x minus 3, if you did something like x plus 3, that's actually going to move your entire graph to the left 3. Whereas if you did x minus 3, it would actually move your graph to the right 3. So the important thing to understand is the number that's with x is controlling the x-axis. That's going to move your graph side to side. But it always is the opposite of what it appears to do. So like x plus 3 is actually going to move it to the left, to the negative side, and the x minus 3 is going to move it to the right, to the positive side. Okay, so that's where we get the principle where we say insiders lie. Now, the number at the very end, if you have a plus, if you have something like square root of x with a plus 3 at the end, that's going to move your entire graph up 3. If you have square root of x and then you have a minus 3 at the very end, that's going to move your entire graph down 3. Okay, so the number on the inside moves it side to side, that's controlling the x-axis, but the number on the outside is moving your graph up and down, that's controlling your y-axis. Now there is one more thing that we could throw in here, and that would be a leading coefficient. So if you have a number at the very front, this is going to be what might stretch your graph out, stretch or compress your graph, or reflect your graph. If you throw a negative in there, it's just going to flip the entire graph over. So let's take a look at how some of these will appear whenever you're graphing a square root function. Okay, so take a look at example number 1 down here. We've got y equals square root of x minus 3 plus 2. So inside here, x minus 3, this is going to move our entire graph to the right 3. And the plus 2 at the end is going to move the entire graph up 2. So recall that the parent function that we looked at a few slides back started at 0, 0. Well, instead of starting at 0, 0, I need to move to the right 1, 2, 3, and up 2, 1, 2. So we're starting right here. Now, the same shape needs to come from that point. So I'm going to go over 1, up 1, because the square root of 1 is 1. And then back to that first point, I'm going to go over 1, 2, 3, 4, up 2. Over 4, up 2, because the square root of 4 is 2. If I had room, I would go over 9, up 3, because the square root of 9 is 3. But it doesn't look like I'm going to have room for that point, so I'm going to have my arch going up and over from that first initial point. Example number 2, we've got y equals square root of x plus 1 minus 4. So the x plus 1 is going to move the entire graph to the left 1, and the minus 4 is going to move the entire graph down 4. So again, the parent function began at 0, 0, but this one I need to go to the left 1 and down 1, 2, 3, 4. So I'm going to start right here at -1, -4, moving the whole thing to the left 1, down 4. From that point, the rest of the points will follow. So from here, I'm going to go over 1, up 1, because the square root of 1 is 1. And then back to that same initial point, I'm going to go over 1, 2, 3, 4, up 2, because the square root of 4 is 2. And then back to that initial point, I'm going to go over 9, up 3, over 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3, because the square root of 9 is 3. If I had room, I'd keep going. The next point would be over 16, up 4, because the square root of 16 is 4. So you're just following that square root pattern, but starting in a different location. Whichever way it shifted, that's where you begin your graph. All right, last one, example 3 here. See x minus 5, that tells me I'm going to shift to the right 5. And the plus 1 at the end tells me I'm going up 1. So right 5, up 1. So instead of starting at 0, 0, I'm going over 1, 2, 3, 4, 5, up 1. I'm starting here. Right 5, up 1. Now remember, there's a negative in the front. So this thing is going to flip downward. So instead of pointing up and over, it's going to be pointing down and over. So basically, instead of going over 1, up 1, I'm going to go over 1, down 1. And instead of going over 4, up 2, I'm going to go over 4, down 2. And it's going to be pointing over and down because I have a negative there, which tells me that the whole thing just flips over. And that is how you graph square root functions.